Hey guys, this is going to be the last video in Unit 8, and in this video we're going to look at how to factor what's called a difference of squares. And so, if you remember in the last unit, if you were to take the binomial a plus b times the binomial a minus b, and you were to go through and FOIL this, you would get a squared minus ab plus ab minus b squared. Okay, so those middle two terms there, negative AB and positive AB, would actually cancel each other out. So you would really get a squared minus b squared when you multiply these two. Well, if you do the reverse of this, okay, if you take a squared minus b squared and you factor it, you end up getting two binomials, a plus b times the quantity a minus b. And so this rule is what we call a difference of two squares, and it's actually a factoring method that we're going to use to factor binomials. Okay? The one catch to this rule is that it's only useful if you can recognize what are called your perfect squares. And so that's the first thing we're going to look at in this video is the your list of perfect squares. So the numbers that we put in this box here, this list of numbers needs to be memorized. Okay, this is a list of numbers that you need to memorize. And you're going to get these numbers from taking each integer, starting with 1, and squaring it. So 1 squared would be 1. 2 squared, 2 times 2 is 4. 3 squared, 3 times 3 is 9. 4 squared is 16. 5 squared is 25. 6 squared, 36. 7 squared is 49. 8 squared, 64. 9 squared is 81. 10 squared, 100. 11 squared, 121. 12 squared, 144. 13 squared is 169, 14 squared is 196, and 15 squared is 225. Okay, so that's 15 numbers there that you need to memorize and be able to recognize as perfect squares. Meaning if I take the square root of those numbers, I get a whole number. Okay, so that list is going to be very useful because if you recognize one of those numbers in a factoring problem, you know that there's a chance the problem will be a difference of squares, and you're going to factor it using this rule up here that we're going to talk about. So let's look at number 1 and see how this works. Okay, so number 1, you'll notice it's a binomial. So the very first thing we always try with all factoring problems is looking for a GCF. There was not a GCF for number 1. And so the only other way to factor a binomial, if there's not a GCF, is to try a difference of squares. Okay, in order to be a difference of squares, first of all, it has to be a difference problem, meaning there has to be subtraction. So I have to have a minus sign right here in front of the second term. If the problem were x squared plus 36, okay, this binomial here would not factor. Okay, so you can't factor anything that has a sum using this rule, but you can factor differences. So x squared minus 36. Number 1, it's a difference. Number 2, you have a x squared. So x squared is itself a perfect square because you can take x times x to get x squared. And then you have the number 36 right here, which is on our list of perfect squares. Okay, 36 is 6 times 6, or 6 squared. So that means that this problem, number 1, factors using that difference of squares rule, and I'm going to show you now how you factor this. Okay, so number 1 is going to factor into two binomials. The square root of x squared would just be x. X times x is x squared. So just like your trinomial problems, you're going to put an x here and an x here. The square root of 36 is 6, and so my second term in each of these binomials is going to be a 6. Okay, the square root of this second term here. And then in order to finish this, you need opposite signs in order to multiply to get a negative 36. Okay, to multiply to get a negative, you have to have a positive times a negative. So one of my signs is going to be a plus sign, and one of my signs is going to be a minus sign. So this factors into x plus 6 times the quantity x minus 6. Okay, number 2, we have m squared minus 100. First thing you look for is a GCF, and you'll notice there is none. Next thing you'll look for, because it's a binomial, is a difference of squares. M squared is a perfect square, and 100 is on our list. Okay, 100 you need to recognize is 10 squared, so I can factor this again into two binomials. I'll put an m here and an m here as my first terms, and then for my second terms, square root of 100 is 10, so this will be m minus 10 times the quantity m plus 10. Okay, number 3, I have 9v squared minus 4. Again, no GCF, but we have a 9v squared. Okay, not only is v squared a perfect square, but so is 9. 9 is on our list. And 4 is also a perfect square. So that means I can factor this into two binomials. The square root of 9v squared would be 3v. Okay, 3 times 3 is 9, v times v is v squared. So we'll put a 3v here and here. And then the square root of 4 is 2. So I'm going to have a 3v plus 2 and a 3v minus 2. Number 4, 25x squared minus 64. Again, no GCF for this one. But it is a difference of squares because 25 is a perfect square, as is 64. Okay, 25x squared, the square root of that would be 5x. So my first term for each one is going to be a 5x. And then your second term, the square root of 64 is 8. So we'll have 5x minus 8 times the quantity 5x plus 8. Okay, number 5, we have 8y squared minus 50. You'll notice that neither 8 nor 50 are perfect squares, but they are both even numbers, which means we have a GCF for this problem. So the first thing we're going to do is factor out that GCF. It would be a 2. So you factor out your 2, and you're going to be left with 4y squared minus 25. From there, you need to recognize that this leftover part here is a difference of squares, and so you have to keep going and factor this further. So we have our 2 out front that we pulled out. 4y squared, the square root of that is 2y, so this would be a 2y here and here. The square root of 25 is 5, so this would be a plus 5 here and a minus 5 here. Lastly, we have 28 squared minus 7. This problem also has a GCF. That GCF would be 7, so I can pull out my 7, and I'm left with 4k squared minus 1. 4 is a perfect square, as is 1, so now I can factor this further. My 7 goes out here, and this factors into 2k plus 1 times the quantity 2k minus 1. Okay, so again, it's a pretty simple rule, but it's one that you're going to have to be careful of and always look for whenever you're dealing with binomials. Okay, so we're going to practice this a little bit next time I see you in class. Until then, have a nice day. You are all wonderful people. Take care.